Okay, all right. We'll start with the introduction to chatbots. Yeah. How many of you, is there anybody who doesn't use GPT? Okay. So all of us are using GPT, OpenAI's GPT, which is a chatbot. Now, any question I have, probably I just ask it and I'll show you some options. I'll share the screen for this purpose. You will have to stop me. I'm assuming that you will understand. So now I'll ask, okay, I'm not keeping well today. What precautions should I take? So now any life requirement, this is a general purpose artificial intelligence. RUA, general purpose artificial, EAGI, artificial general intelligence. So how do you describe artificial general intelligence? Now, so we are having a chat here. So there is, we ask a question and it is answering. Now, there are very many different types of applications that we can use. Just see how OpenAI's OpenAI's GPT alone has so many APIs that are created. Let's say I want to see um, a question on research and analysis. So I want to do AI research. Oh, there are so many different types of chatbots already created using the GPT here. There is something called research. If you go there, um, so we have so many options here. So many options. Let's see, ask your PDF research assistant or this is research and analysis education. Somebody has built a math solver, your advanced math solver. Someone asks a question, um, what are powerful math models? So there are, I think Google, so DeepMind has a very powerful math model, and there are several of them that we can see. Let's see how um, this would answer. So here we can ask a question. So the easier questions are find eigenvectors and eigenvalues. We have answer here. Let's see how this linear algebra eigenvectors can be computed. What happened? Where is this? What are eigenvectors and eigenvalues? Give an example, 2 by 2 matrix, and compute. Is this a complex problem enough? Is this a complex enough problem? And do you see the answer here? So the steps that it followed, okay, I'll compute eigenvalues first, and then there is identity matrix. Then determinant is computed. Then, yeah, eigenvalues are defined. Now the next is eigenvectors. So there are steps that are followed for eigenvectors. And there is an explanation that is provided on the key concept and how it is responded. I'll just want to ask this question. Has this clarified that it can solve complex mathematical equations?
Yeah, okay, sir. Thank you.
Okay, so that's one example. So now what I'm also trying to do here is show you different chatbots that exist. The next chatbot that all I'm doing is using only GPT. We are not even going anywhere at the moment. Let's say I want to create a PERT chart, a diagram. So I want to create a diagram. So we'll do two examples. We'll generate a video generator. Let's try a video generator and see. Um, not a, we'll just look for a video generator. Text to video maker. My engineering, my faculty at VNR. Is this correct? VNR Engineering College?
Yes, sir. Yes.
Okay. Okay. I'm a faculty at VNR College. I want a 30-second video talking about our authority in machine learning and the subject matter expertise we have in ML discipline and consulting. So now what did we asked, okay, I'm faculty, I want a 30-second video where we are good at machine learning as a college. So it has provided a narrative. One narrative it gave idea one, welcome to VNR Engineering College where innovation meets expertise, our ML program stands up, blah, blah. There is second option. So let's choose idea two. So two. Not just educators, they are industry and subject. Our students gain real world insights and advanced skills. Okay, now create video. Okay, so it says your video is being generated. It will highlight expertise. Click here. Please note this is only free version. It is still very much worth experiencing. Let's see what happens. Earlier I used okay, I don't know if I have. Just a minute. I've shared someone video earlier. Okay, so not able to see, but let's see. Okay, just give me a minute. Okay. So we already gave text. Why did it not generate? We have already given text. It should have generated for this. Let's see again. The submission. Audience, students, inspirational. Okay. Let's just wait and see what it generates. So all that we asked was, okay, give me a 30-second video about our expertise in machine learning as a college. Okay, so this is one. While it gets ready, let's go to something else. We saw two aspects. Now, let us also see a research where you have a big article, a complex article, and we want to ask a summary of that article. Which mm, so quantum physics can be a complex topic, or is there any other topic that we want to choose? Mm, PDF on theory of relativity, the special and general theory. Okay, so we have something here. Download file PDF. Auto PDF. Okay, let's see if download works. No. So I have a problem to use this on. So I'll run it on Chrome. Let me see. Just a minute more. I think Safari did not run the video, so we will try it in uh, Chrome. Chrome now. Same thing we'll try to run in Safari in Chrome and see what is going to happen. So this is the text that it created, and we have approved this text. And we want to see for this text, well, whether it can generate a video or not. Now, while it starts, let us also try this PDF, how well it can read the PDF. The name Einstein theory of relativity. Has anyone tried asking questions on the PDF document and the Mohammad Rohul Amin and James on last motion? We'll ask these questions. Let's see what file name. It should not be. Okay. Give me a summary of the article. Let's see how is it going to answer. Oh, hell. All right, no problem. Let's go to regular one. Forget those high-tech exclusives. There could be some issue with the attachment. All right. So we have given a 20 odd page document and it asks, give me summary of the article, and then it is explaining us. It says introduction and historical special theory of relatively general theory, mathematical foundations, blah, blah, blah. I am a physicist. I'm a researcher in mathematics. What references from this article can I make? All right. So here are two questions. Now, one, we have given a 20 odd pages article and we asked for summary. It gave us in few seconds the summary. Introduction, theory of relativity, special and general, mathematical foundations, experimental validation, and so on. So once, and then if you want only a specific aspect, I am a researcher in maths, what reference can I make? So then it has provided Lorentz transformations, obviously, that is connected to mathematics and other aspects. So any aspect of that article, if you want to extract or make a summary, now it becomes a lot more easier. Suggested references. So there are other references. What can I pick from the meaning of relativity as a mathematician? Let's say, what can I pick from this? So from this book, what can we exactly take inspiration from? So these details are also provided. So now I'm hoping any document, any book that you want to take a gist of. Today it is easier to chat. Would the audience for the video that we asked for 30 seconds? I'll just proceed with students to avoid delay. It is now going to the video. We'll wait. While it generates video, let us come back to, are there, now today you look at HDFC Bank
Sir, voice is breaking. Your voice is
bank has the chat behind the scenes and make it work. So interface, you can have any interface that currently using HTML, you create a search button and say, now that's where I will look at. So using that search, I want to have a interaction with the chatbot. That is also possible. So interface is one aspect. In the back end, the model is this another aspect. Now the model can be more rules bound, like only when it matches a string, or you do the lemmatization and stemming, and the root word, if it matches to the root word, it can answer. Or today's financial services in India have gone to an advanced level where they use chatbot. Shall we watch this video that it created? Let's see what it did. Get this.
This is why you need VNR's ML faculty. Learn from the best to be the best. Step into your future with confidence. Imagine learning from the very minds who shape the future of technology. At VNR, our machine learning faculty are industry consultants and subject matter experts. They don't just teach you about algorithms, they've built them. Our faculty's real-world experience means you get hands-on learning with current cutting-edge technologies. You won't just study theory, you'll apply it in practical, impactful ways. Picture yourself solving real-world problems before you even graduate. Step into a classroom where innovation meets inspiration, where your ideas are nurtured and your skills are sharpened. This is your chance to learn from the best, to become the best. Join VNR Engineering College today, and let's turn your passion for machine learning into a successful, future-ready career. Ready to be a leader in tech? Your journey starts here.
How is this video? Any comments? Yes, somebody has to speak. Any comments on the video that you just saw? So I now have given additional information. Am I audible?
Yes, sir. Yes, sir. Now it is okay. Earlier it is
Okay.
some voice breaking is there.
Okay. So then let me use this. And have you heard this video and watched the video?
No, sir. Once play.
Okay. Let's see. Let's see.
This is why you need VNR's ML faculty. Learn from the best to be the best. Step into your future with confidence. Imagine learning from the very minds who shape the future of technology. At VNR, our machine learning faculty are industry consultants and subject matter experts. They don't just teach you about algorithms, they've built them. Our faculty's real-world experience means you get hands-on learning with current cutting-edge technologies. You won't just study theory, you'll apply it in practical, impactful ways. Picture yourself solving real-world problems before you even graduate. Step into a classroom where innovation meets inspiration, where your ideas are nurtured and your skills are sharpened. This is your chance to learn from the best, to become the best. Join VNR Engineering College today, and let's turn your passion for machine learning into a successful, future-ready career. Ready to be a leader in tech? Your journey starts here.
Okay. Okay.
Somebody
So,
posted again. Repeat the steps in the chat box. How you created this video?
okay, give me another topic. Let's ask. We are interacting with the chat bot. Give me a topic. On what do you want a video to be created?
Talking about the chatbot itself.
Boring. It is very boring, but it's okay.
Discuss-
I can ask because it can be boring. But let's say.
Or else
So,
about Kalki movie.
movie. Okay. All right. But what is the probability it would know about Kalki? Explain about it. Explain about Telugu film, Indian film industry. Indian film industry in 30 seconds.
Sir, share the screen, sir. Screen.
Oh, okay. Because how to select AI job course. Okay. Explain about choosing right AI course. Are you able to see the screen? Course for the job. Provide various AI courses and recommend jobs. But I don't know in 30 seconds. Let's see. Let's see what it generates. We can do one more thing. We can ask the same question to GPT. You can ask GPT this question and say, and give an answer. We'll see what this is going to answer. It is generating. Just a moment. It's not yet complete. It is processing there, adding a new chapter with a course. This guy, to your question, what is the question we asked? Explain about choosing right AI course for a job, provide various and recommend jobs. Okay, choosing the right AI course. Introductory machine learning, deep learning, NLP, computer vision, reinforcement. See, interesting. Whatever we discussed. NLP, text processing, computer vision, image processing. The fourth method is reinforcement learning. Basic machine learning and deep learning refers to predictive models. Okay, AI ethics and policy AI for business. Recommended jobs. Okay, good. All right, we can give this content to this video to generate a video. Okay, I think video is generated here. Let's watch video, what it does.
This is why you need VNR's ML.
It's not it. It is still processing. Unusually long time. Normally it takes just couple of minutes to build, 2-3 minutes to build. It is now taking more than 3 minutes, right? Let's say here we ask generative video. Okay, one. Okay, so here I ask this question while we are looking for our video to be generated here. It is still running. Now setting the music volume. If you can see the screen here, the small text, it shows our prompt is given here. Explain about changing right AI course for the job, provide various courses and recommend jobs. It says adding a new chapter with AI recommendations, chapter 2 done, changing the duration of the new chapter to 30 seconds, adding motivational music to the chapter, setting the music volume for the chapter, ensuring the narrator's voice matches the new chapter. Now processing. So let's see these steps. While it does its steps, here we asked a question, generate a video, and then it gave two options. Narrative 1 is a fast-paced introduction. Narrative 2 is highlights the top AI courses and specific jobs they are best suited for. I chose narrative 1, and very quickly it gave this text. Okay, now somebody could generate this video for us. Who can generate? Let's take this text from here. Go to, oh yeah, you can give this text here. And I'll also create this video somewhere. Just a minute. All right, I think our code here, our video here is generated. I think so because explanation. Oh, volume change failed. Sorry. What's wrong? Now, this is the text that we provided here. And let's see if it can generate a video. Did not generate. So we're going to give.
I generated video. Just I'm sharing.
Okay, done. Okay, you want me to play this video that you just generated?
Just.
Safari didn't work last time. Let's see. No, in Safari it is not working. Maybe do you want to show your screen only?
Yes. Started.
Stop wasting time on mediocre AI courses. Discover how to pick the best one for your future. First, get crystal clear about your career goals. Does the course align with where you want to be? Look for comprehensive curricula covering key AI topics like machine learning, deep learning, NLP, and computer vision. Check the prerequisites to ensure you meet them. Evaluate the instructor's expertise and the institution's reputation. It's essential. Balance theory with practical projects. Hands-on experience with AI tools and frameworks is a must. Networking and mentorship opportunities can boost your learning experience. Finally, read reviews and alumni feedback to see if the course really delivers. Choosing the right AI course can set you on a path to success. Ready to make your move? Dive in and start learning today.
You've seen some.
Okay, so any comments on what you saw so far? Any questions or comments on what chatbots can do? Okay. All right. So I will now share some more details of how. What do you want me to share? Okay. So would you be familiar with um, how chatbots are built, how NLP text processing models work? All right. So what exactly do you want me to teach you folks now? What would you want to know? Okay. All right. One transformer architecture. What else you want to know? We have about 1.5 hour time.
No, sir. Like actually, you asked, no, like how chatbots might be working. I mean, maybe the backdrop of the working of chatbots is the transformers architecture, right? That's what I intended to say.
Okay, perfect. I think this is good enough for me to continue. So I'll do it in 2, 3 ways. Number one, I'll talk about what happens in a typical machine learning model. One. Number two, we'll talk about how those vectors have come up. Three, I'll go to transformer architecture. Four, we'll try to explain whatever you just saw, how it worked, we will do. These 4 things we will do. Let's build a chart. Okay. First, building a chatbot. What is LDA? What is LDA? Okay. I tried to run one chatbot. So I'm sharing the screen, and then along the way we'll explain. All right. So during the break, I have created a virtual environment and I have pushed some old code here to see if any of it could work. So GPT-2 was one such. But before I go here, I have to give some introduction to what transformer is and how these contextual word representations work. So give me a minute. I will share these three step by step. All right. So you're able to see the screen, right? So now let me go to point. This is somebody in Bosch wanted some help, so I tried to teach them something. Okay, so this can be a good starting point for us. So forenoon, somebody asked, okay, what can be my research? I see machine learning has three things. One, you can do data analytics, you can process an image, you can process a text. You can also use it for gaming, reinforcement learning, Markov
Sir, getting the network issue at your end. Voice is breaking continuously.
So now chat. Okay.
Voice is breaking, sir. It's stuck.
జబ్బ కాల్ చేసి కాసరా రమ్మని చెప్పు ఇద్దరెళ్ళి గౌతమ్ తీసుకొచ్చుదురు.
Okay. Is it any better? Better now? I changed the internet connectivity now.
Now it is okay, sir.
Okay, now it's fine, right? All right. I'll just repeat. Just a moment. All right. So let's go to. If you have a problem, once again, you let me know. There are I think, two core concepts that you are familiar with is one, neural network methods. So I spoke about in the morning and you are aware, if you have in this picture, x1, x2 are two variables. Let's say this is height and weight, and you are trying to predict the age of a person. So earlier you had only two weight matrices with a constant bias value. In case of artificial networks, you can drop more layers, thereby you will have more weights. The more weights can result in higher accuracy. So that's how network model, but you skip rest of the details. I will go to where we have text processing. So text processing, this is one of very old methods where we have been trying to take help of machines for conversation purpose. So it started to help patients, Rosarian therapist. So it was a string-based approach. In 1980s, we had Wharton has come up with a dictionary on how to break. Yeah, Pennsylvania University has come up. Wharton is part of them. Has come up with syntactically annotated uh, branches of the text where they looked at the relationship between words. This is all part of machine learning. So then in the pre-machine learning era, then statistics and machine learning came where we started converting the words into the one-hot encoded format. In this example, you notice what is the question mark behind left chair table. Now there are how many, 3, 4, 5, 6, 7, 8. So there are, okay, even if we remove 8, so what is behind the table? Unique words are 3, 4, 5, 6. 6 unique words. These appearing 2 times. Behind left chair table. Okay, left hand chair remote. So so looking at the total number, we are creating the one-hot encoding vector size. So that's how initially it was formed, and so on and so forth. Here there are 3, so we use 1, 0, 0, 0, 1, 0, and 4 colors. So you have a vector length of 4. Now this is a fast. Now come fast forward. We will look at very much. So. I'll take some other. Now, when we have a very high, very large vector size, what we started noticing was that there is a good relationship between words that is happening. If you notice in this graph, you have boy, child, infant, girl, assuming that it is just a two-dimensional vector. Otherwise, in a very large dimension, it works. So you notice that the boy, child, infant, girl has a closer relationship. That's why they are all together. Now, grandfather, man, adult, woman, they are closer together because they're on the age side, it is working fine. Now, if you look at the gender side, you will see boy, man, grandfather together and girl, woman together. So automatically these large vector lengths for each word, they started showing the relationship more strongly. This is the second great innovation that happened. So first one is the neural network. Second is vectorization of words that provided insights. So then the next step from here, it happened in 2018, was the transformer architecture to understand each word's meaning more effectively. So here, this is a busy slide, but then I will try to break it into small pieces and provide you. Um, so now the whole idea is how do you create those vectors? Vectors was the question. For each word, you need to define. Let's take this example of a word what, and what is represented in 512 dimensional vector. So you call this as embedding, right? 512. Now, to define the value, and each value can be some, I think, 0, 0.14567. So it is in decimals. You can even have minus each dimension value. Now, to determine this, what in the transformer they did is they used this concept of all attention is all you need. So they said they use this the thought process of a typical search that happens online. If you look at when we want some video online in YouTube, we will search for play Sita Ramasastri songs. Now, when we type something like that, it's random, but let's see. So I will type in YouTube play Sita Ramasastri songs. Now, this is my query. In this query, which is a key between the three? Now, each of them are unique by themselves. So it will start with songs being a key. So in this query, songs being a key, it will go and look at the entire YouTube database, which is pointing to songs. Then it will look at songs of Sitaram Sastri. So then it will start fetching, or it will narrow down all the songs to whatever lyrics written by Sitaram Sastri. Then, now that the values are identified, what is expected is play. You don't even have to say play because that is imperative. So it will show Sitaram Sastri songs. So the query key value is the concept that is utilized in query key and value. In transformer architecture, we'll go into it. Attention is all you need. It says that if you can have a mechanism where the data attention is all you need is you're seeing your own data. Whatever you need, you pass a query through key, you fetch a value. Now, how does it happen? What are the things that they have done? Any input that you provide at the bottom, this input is converted into some sort of tokenization. It gets tokenized. Each token is then converted into an embedding. Now you have a series of embeddings of some values. Now these embeddings, each embedding will have a weight matrix, the multiplier weight matrix, and it is passed through. When it is passed as a query, as a key and value. Okay. Now we use a softmax. I may not remember exactly.
So query into dot product of query and key divided by, I think, whichever, I think square root of 10,000 or 50,000 into value. Something like this, or this is not square root. It is square root of all of this data. Now, irrespective, the whole concept here is query and value. Value is looking at the query is the concept. The next thing that happens is in transformer architecture, the data, this a matrix that we have, or the values that we have. So when the moment the embedding is multiplied with a matrix, you have values. This is passed through different attention heads. Now, each attention head is some sort of an abstraction layer, or you can say attention layer. Let's say we are using 16 attention layers or 8 attention layers, some number, 8 attention layers. This matrix is passed through 8 in 8 abstracts. It is broken into sort of, just for visual purpose, you imagine that it is broken into these pieces, and each piece goes through one attention layer. An attention layer will have this relationship, query, key, and value, and whatever you get as an output, they all brought together. I will just give a pause to ask a question. Do you have any question till here? Okay, I will continue, hoping. Thank you. Continue. So now, what happened? An input is taken, tokenized, converted into embeddings, and embedding is passed through an attention layer. Attention layer takes an abstract of each of this embedding, and it passes through this looking at each other, query, key, and value concept through a softmax, and the output comes. Now let's look at how it looks like. You see at the bottom, the rock rules. So we have these sequence identifier. There are many ways you can identify a sequence. And here I think it uses sine curve for sequence identification. So you see 1, 2, 3, P1, P2, P3. So it's a small value that differentiates them. In any case, you have now this input. The input has gone, the D is, let's say, it has a nomenclature of X47. A input is the embedding, and it has gone to A attention layer. So here, the softmax, when it is applied, you have. So these three are the inputs. Now you see A, B, and C. So transpose or in some format, they are together. So this is where we are saying they are looking at each other. Now it passes through these dots. You can consider them. Okay, these are dots are data drawn from other embedding, and yeah, you have dropout to reduce the overfit. So some percentage you can drop out. At every level, we do the normalization. You normalize the data so that the size of the data does not go wider. And so once you normalize data, pass it through ReLU, an activation function. What is the purpose of using an activation function?
So to bring linearity.
Yeah, you quash the data and you try to distribute them well. While you normalize makes the data to a compressed size where you keep mean to 0, standard normal distribution. But the activation functions can bring the kind of linearity that you are looking for. If you want to make adjustments, let's say ReLU, rectified linear unit, what it does is it removes all the non-positive values. Anything below 0, it will consider as a 0, and rest of them remains linear. So yeah, you can use whichever leaky ReLU. Some people started using last 10 years. We have been using leaky ReLU so that we don't, the negative values are divided by 10. We still see the negative value existing, but then smaller. Perfect. So to quash the data and bring to a shape that we want, linearity that we want. So again, then again you normalize it. The normalized data goes out. I will now. So this entire piece till here, from A input, B input till the normalization that you got, is called one block. So like this, there are multiple blocks in transformer architecture. So there are 12 blocks on each side. There is a, so far we discussed three things. Number one, you have data. Data is tokenized, is embedded, it's moved to embeddings. Embedding went to looking at each other, where it is looking at each other through query key value concept, and it gets processed through multiple attention layers, 4 or 8 or 16 attention layers, so that the speed is higher. Now, after it passes through the attention layer, you're making sure it does not overfit, you drop out and normalize the data. After normalizing to smaller values, you try to fit the data using an activation function, again do some bit of dropouts, and again normalize the data that is that you have fit. So all of this is one block. Now I'm going to a next step of what happens in that one after the one block. Now what you see here is you look at the left hand side. We spoke about inputs becoming embeddings. I also referred positional embedding. You could use either a sine curve or some sort of a number that will signify where the word is. So you add that to the input and push it to the block. The block has an attention head, multi-attention head. The output of the attention head gets normal. Adding is, you also take, if you have noticed in any of the pre-trained large networks, you will see these skip connections often. So you take the initial data and add it to the processed data. The whole reason for this is sometimes in the processed data, you will have losses, more loss will be there. To avoid the nuances, slightest nuances not to be missed out, you enrich it with the input. And that is now became an industry norm. Every model we start, it makes computationally intensive, but then we are hoping that the slightest detail is also not missed from it. All right. So here you see three, assuming there are three attention heads, but it can be any number. Now you normalize data. So feed forward is where we looked at the activation, radio activation. After the activation, again, you are looking at the previous data, you add it and then normalize it. Now, like this one block in a transformer, typical recommendation was you will have 12 blocks for a small transformer and 24 blocks for a bigger transformer. That's where that gave birth to BERT, bidirectional embedded representative transformers. I'll give a pause before I go to the right hand side. How are we doing? Okay, tell me what can be an answer for a question, how are you? What will you answer for this? Anybody? What is an answer for how are you? Okay, make it a sentence. Okay, all right, I'll go with this, I am good. Okay, now this is the question we passed. I'll keep it in this manner. The question here is, how are you? And it goes through either one or multiple blocks. And this has, here it is showing, it is connected to a layer here. And here it is also showing outputs shifted right. All right. So when we ask the question first, there is no output. Output is 0. But there is no output yet. So therefore, this particular block is 0. Now, this particular block, So this is the block, right? Or this is all full block, and this particular attention head has no value initially in the first round. Let me put it like this. This has no value. Now directly how are you as a collective data, the embeddings which got processed here will go to this attention head, from here feed forward. And if you have, let's say, 12 blocks like this, it passes through 12 blocks. After that, all our blocks are like this only exactly. Passes through and it gets linear and soft max applied. And what you get as an output is very, very likely for this is I. Now what happens is this I then becomes an input here. Now I goes here, I gets processed here, whatever are the embeddings of I, and now I is now added here with the past data. How are you? Now this essentially here, if you look at exactly here, at this stage, if you look at what you would have is, how are you? And then I. So that gets processed linear, and then it gets feed forward and so on. And then it spits out am. Now what happens is that I am, both words come here as an input, as this output. I am goes here, and here suddenly you will notice that in this phase, now you have how are you and I am. The I am. After that, it again goes through the steps here and it spits out the answer as good. This time you have all three words coming as an input here. I am good is going here like this, and it passes through here, and suddenly here it gets added, and now we see here there are more inputs. It says how are you is there, I am is there, and good is there. So it passes through this layer and linear and softmax, and suddenly realizes there is no output. So no output here. So it gets terminated. And then the moment there is no output, it just gets terminated. When it terminates, it gives you the answer of I am good. This is the answer, becomes final answer. Is this making sense? Or what questions or thoughts do you have?
So, sir, it does mean that entire answer, entire answer is produced, the question will alive.
It will keep. Question continues until it gets terminated. Termination can be where you limit it, saying I don't allow more than 3 words, or more than 5 tokens. I don't allow more than 10 tokens, or you keep a threshold. You cannot give an answer if the threshold is less than 0.3, 0.4. You need to terminate. So there can any of the two can be a reason for termination. Good. Any other question, view? All right. So here, if you notice, I kept saying that this transformer has an encoder and decoder. By the way, this one more point that we spoke about. Output is probabilities. You have all the 27,000 words as a probable response every time, 27K. Whichever has high probability, or if you keep any validation, so that you don't allow certain words, so it filters out those words and so on. So it is based on the probability only these words are spit out. Okay. One second aspect I want to share. This side of the block, this side is called encoder block. Now, it is intuitive for you also to say, and this is called decoder block. This is decoder block. Now, it is intuitive for us to look at encoder block is very, very good at processing text. So it processes text very well. Okay. Now, tell me what is the purpose of a decoder block, primary purpose? What is it doing here, decoder block?
Encoder processes, decoder generates.
Perfect. Perfect. It is generating as output right here. For us, it is giving the this output. So decoders are good at generating. So decoder block is generation, and encoder block is processing text. Now, what happened after 2018? 2018 is where transformer architecture and BERT was presented, right? BERT was presented by, no, yeah, 2018 BERT was presented, and they first showed transformer architecture, and then they said, attention is all you need. So he is an Indian origin person, the core author. All you need is written. After this, 2019 and 20, uh, OpenAI has chosen, and the BERT is completely relied on only encoder. It does not even touch the decoder at all. So Google initially only emphasized on the encoder because processing text is their focus area. OpenAI, on the other hand, came up with generation models, came up with generation by using decoders. So today you have all of this is the output is coming from the decoder side only. All right. With this note, I have now. Okay. So now I kept sharing weights are the multipliers, right? The output of any algorithm is weights. And now if you notice here, this particular graph, the number of weights, model size means number of weights. Initially, these were 100 million weights, and we felt, how can you have 100 million weights? How do we handle? But then 2018, 19, so that's how it has been. And suddenly in 2020, 2021, there is a 8 billion Megatron was built by NVIDIA. So those of people who are smart, they have purchased NVIDIA shares in 2021 after this model was built. I think they made millions of dollars now, whoever has invested in that company 3 years ago, because its shares have increased by so many times now, NVIDIA. In any case, then we had Megatron by NVIDIA, and Meta has built. Then we had GPT-3, which was like shockingly 175 billion weights that it had. So very, very, very large. So today, a question that we ask that passes through so many. Of course, there are also parent and child models. Sometimes the answer comes in an efficient way, but then the whole architecture has 175 billion weights. Very complex that way. Very, very, very large. This is one aspect I will share. Now, so some of you might have seen how GPT-3 is built, and this is the concept of reinforcement learning also. So what they did, simple model development was not giving full accuracy. So they had used experts to provide answers. So I'll share this slide. It is available openly. They had provided answers to set of questions, then posed these questions to the model, which is trained on large data, large internet data, Rediff data, or chat data, that Microsoft Teams data. Different companies build models, and they train on the text. Now that, so the set of questions are given to the model. When it gave answers, then correct answers are provided to it. And say, now you go and see, check how many of them right answers. So, or experts started reviewing which of them are right answers, which of them are wrong answers, and give the feedback saying, look, to these questions, you gave these as right answers, but these are all wrong answers that you provided. So when this feedback is provided back to the model, then it had gone through, we call there are multiple algorithms in the reinforcement learning. You could apply one of the methods to then refine the model weight matrices in such a way that these questions will generate right answers. This is the another concept that I could introduce. Any question? Any question so far? So the next part that I could share with you is how when we have to build any software, there are some pieces that we need. I'll talk about those pieces, and also will share with you which is taking maximum time. So building a model is at the center, if you notice. But then to build a model, we need different steps to be completed. One, a chatbot that we want to build that answers questions to your students in the college. Let's say existing students, if they want to know what is the timetable for exam, what are the dates for the college, how is the evaluation taking place for each subject, how many marks are there. So today, who is answering all these questions to your students? So these questions, either they ask the faculty or administrative office, or your website may have the data, or some circulars you send. That is how. Another way is you create a chatbot where you feed the model with all possible FAQs and keep it. So for anybody to build one such model, they need to understand how academic education system works. Then they need to understand, okay, what are the things that we can improvise. Children, some of the students may not articulate views in English properly. Sometimes they write it in bilingual Telugu or English and so on. So, and then get all the possible questions that people can ask, then do the cleanup of the data pre-process. So in this example, it is small because the number of questions could be some 300, 400 a student might ask. Yeah, but then in terms of let's say GPT kind of thing, it is answering questions on all the disciplines. How much of data you need to provide to it to become smart? Yeah. So all of that data. Oh, 1 second. Okay. So all of that data gets pre-processed. Then if we build a model, we will just look at how a model can be built. And then once a model is built, let's say the performance is not up to the expectation. So you will go make changes, fine tune the model in such a way that the performance is improved. Then you create APIs, Dockerize, and deploy and maintain. These are the steps. So you can broadly break this into three pieces. One is business scope, orange color. Second is technical scope, gathering data to building model and enhancing performance. And third is DevOps, deploy and maintain. All right. So now when you have to do these three things, yeah, what all data scientists can do, you can look at, I think you are familiar with all, who a data scientist is. Somebody who is doing data processing, visualization is also a data scientist. I spend in machine learning, that's my area. So, or neurocomputing, pattern recognition, all of these can become part of data scientist. Now let's look at if you have to build an algorithm, what are all the pieces involved over there? Now, number one, so let's say it's already there. We have we have pre-trained model available. To build any model, number one, you will have to get the pre-trained model libraries to be imported. And typically libraries are, you need a tokenizer, you need an embeddings, you need the model, pre-trained model. Okay. Once you have this, then they will have a format in which question can be asked. I will show now an example where you can ask a question from a para. So there is this popular squad test, right? Stanford question and answer data set. Question and answer data test, where you provide, it's like reading comprehension. You provide some text and then you ask a question on the text. Ask question. It should be able to answer. Now, shall I show you a demo of some piece of code that is using such pre-trained model? And we provide context and text. I am going to go this file name. All right. So let's see GPT-2. Now here, transformers is a package. In the transformers package, you have GPT-2 language model, LM head model, and then GPT-2 tokenizer. We need a tokenizer, and embeddings are built into the head model itself. We need both of them to be imported. And import torch. Okay, import torch, because some script is written in the torch. So let's run this. And now what I'm doing here, model name is GPT-2, and I'm passing to a variable tokenizer where from this tokenizer, from pre-trained, and the model name that I provide here, GPT-2 is the model name. So from pre-trained, this is where I'll be able to break a text into small tokens. Then to the model, I will store GPT LM head model. This is what will run. And within this, the parameter is GPT-2. Probably GPT is another parameter which is there. I never used though. So I'll run this. Now I have in my tokenizer and model, the model is running. Here, I'll construct a function. So in this function, function name is answer question. And within this, I'll provide a question and context. I'll pass these values. Then the process that is happening, a simple process only, will show input text. So I'll show what is the input text. The question is, context is mentioned here and question is mentioned here, just a single line. Then input IDs. This is where I am tokenizing the text data. The input text is going there. Then any special tokens allow. And this is another hyperparameter. You can just keep tensors. So now input IDs have this entire data available. Both question and context is available in the input data. Now I'm going to generate an answer. For that, output is use the model. In the model, generate, use input IDs. Length has to be length could be under 200, and number of written sequences are 1 or 0. You can limit. It should not return more than once. So then you can keep 0. Generated text. You decode the generated text from whatever format is available into using tokenizer, normal English, and return the English. So I run this application, I run this function. Now all I have to do is call this function. Let's say, here, All right. So the question here is, we can ask question. Okay, is my voice clear? You're all able to hear my voice, right?
Yes, sir.
Yeah, thanks. Thanks. Yeah. Okay. So here we can give any question answer. So we can ask, let's say, uh, give me a sample, give me a 2-line context about India and a simple question from the context. Okay. Now, India, known for its rich cultural heritage and diverse traditions, is also one of fast-growing economies in the world, with significant advancement in technology and education. Let's use this as our context. It's okay, whatever is the context. Now, in this, the question that it says, what are some key factors contributing to India's rapid economic growth? Now, this is the question. Let's see what is it going to answer. Now we are saying answer is answer question. You just execute this function and where pass the question and context. Let's see. Now, so this is what is the context that we provided. Question is, what are some key factors contributing to India's economic growth? It says the country's economic growth has been driven by the growth of internet, which has helped to drive the country's economic growth. Let's ask one more question. What other questions can we ask from it? What is India known for? So now, what is India known for? India is known for its cultural heritage and diverse traditions. Let's ask what is India? And see, it is GPT-2, very old, 2021. India is a country of more than 1.5 billion people. It is home to over 1.5 billion. Yeah, it is. It is using its knowledge now. Now, like this, if I don't want, let's say, I don't want this to return multiple times, then I can limit it to don't repeat. I can limit the repetition. Number of only return sequence is one, and do not repetition I can avoid. I can add extra piece so that it will not repeat. Let's say here, I'll ask the same question here and run this and see what happens. Okay, and context is this. Are you on DRM? Let's see, I'll run this. Yeah, and this is answering. Here, I have not repeated, I did not ask for providing the context and all, just answer the question and said, is India. India is a country of more than, it is home to over 1,000 languages, blah, 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 blah. And then it is truncated because I kept maximum length as 200. It has given this big. Let's say I keep the maximum length as 20. And let's see the answer. The answer size will be much smaller now. Okay, input IDs themselves, if you notice here, there is an error. The input IDs themselves are, where is this? So here it says input length of input IDs are 43, but maximum length is set to 20. What can I answer for you? I can't give you any answer. So let's go and change this to 16. India is country of more than 1.5. It is home too. It stopped here. All right. So does this make sense for you? You're able to see? Okay. Now, if you provide an interface to it, then automatically this answer will appear there. And you give the context beforehand. All that the user should ask is only the question. Answer should be given by itself. So that also it can handle. And now, if we have to say answer underscore question two, let's say here I will use two. The answer is short. Say, small mistake, I'll keep it 100. Yeah, answer is short. The book is about a young man named blah, 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 who is sent, the school is called, so and so. So, and it is not repeating here. Yeah. So this is the answer it has provided. I will now go back to what other aspects that you have asked for. Couple of things that you asked me when we started the session. I'm going to the questions that were posed in the beginning. What is federative AI? So now federative AI is federative learning, where uh, if you don't want to share your data to others in any way, then you tokenize the data and give only the pieces of data together to the consumer, to the model developer. So when you have 10 such data sources, and all these 10 companies or 10 individuals, they don't want to give the data as is, but they can encrypt the data and provide. So under such circumstances, when you have a distributed data input is going, such learning methods are called federative learning. And if you use them, then it is called federative AI. Next question, what language models are best for mathematical equations? We already saw. Uh, there are so many methods that you can look at within the GPT itself. Uh, but then Google's DeepMind models are fairly accurate for mathematics. So that's why if you do in the search, they also provide good answers. Yeah. Next, somebody asked, Government of India's, are there any language models? So I read that Bharat GPT, some core-rover.ai is building this language model, and it is also in Telugu, Tamil, and many other different languages. Then India AI Mission, High Power Committee are some of the other LLMs that are going on. And if you can look at which all models have asked for approval, so that can provide clarity on an ongoing basis. All right. Any question here on these 3 points? Okay. Now, so what are the chatbot use cases and design considerations? Building chatbot with pre-trained generative AI models. I will talk about one architecture. Yeah. Now, what happened with this entire large language models being available in Hugging Face? Are you all familiar with Hugging Face? If not, Hugging Face. Yeah. This is one place under the sky where you have so many language. Okay, just leave it. So here you ask for a model that you want, and you will find here. let's say you want this Hugging Face, you can go, this is a free sign up. All models are open source libraries. If you have anything on Hugging Face, this is the open source. Now I want something question answering task, question answering. So you have visual question answering, simple question answering. And I click this, I will have, where is the question answering? Let's say somebody referred to summarization. So there are so many 1,883 models available for summarization. You can take BART large of Facebook. 5.38 million downloads are there. It is used for summarization. Distill BART by Schleifer. He's got so many models. At least 50 models are uploaded by him or his organization. Google has another hundreds of models here. So like this, any work that you want to do, now you don't need to build question answering. Let's see question answering. Roberta base, I don't know, it is still appearing as in the top, but Llama 3, 8 billion instruct. So this is another model which is quite popular. So you can just go there, take the, look at something else, Roberta. So you can go here, look for what hyperparameters and how do you import, how do you install this library, and they have provided from transformers you can import auto model for question answering. Deal. So you just take this code. This is the model name, deep set Roberta, and the way we ran here, GPT-2 here as an example. You go change this model name, whatever is the, however they want to call the data, they have provided here, utilize and move and utilize it. All right. Now, if you want models in computer vision, so you can look for computer vision models. See, depth estimation, image classification, image to video or text to video. So you have text to video model. You can take this model, you can call the model, and if you want to fine tune, but that itself is painful. You just utilize the model and get your text to video generated. I have not tried, but building, you could give it a try. You will have all the necessary files. All we need is how to use, what is the library and how do you use. Let's see. And Creative Commons, CC means you can use it for free, Creative Commons license under Apache. Model scope, and so on and so forth. All right. Okay. You have to install diffusers, transformers, accelerate, torch. Then from diffusers, you have diffusion pipeline, DPM solver, multi-setup scheduler, and so on and so forth. You get this. So here the question, the prompt was an astronaut riding a horse, Darth Vader surfing in waves. Those of you who watch. And so on and so forth. So how do you use? So one resource that you have to consider is Hugging Face. Let's say you want to work on some data sets. You can go to data sets, whatever data sets that you are looking for. I want only text data. So go for text data sets. So you have, yeah, 237 million Hugging Face, small m corpus. It has 237 tokens available in 237 million tokens available. I think this is 237 million tokens. So you can use it to fine tune your model or to build a model. You can use this data set. If you want predictive analytics, simple data set. So you look for tabular data. So tabular data in CSV format, or let's say this item. Yeah, tabular data in CSV format. I will have Ibrahim Hamanchi 151,000 records. What is this data about? Terms and conditions, blah, 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 blah. So you basically, okay, these are also images, but in a tabular form, process data. So you can say predictive analytics. I'll see if it works. So data sets, let's say. Simple data I'm trying to look for. Tailor to Vietnamese. What could this be? The data on. String length. Okay, there are a lot of text here. So you could look for simple data. These are all heavily onto text and image basis. Obviously, that is where you rely on the third party information. Otherwise, there are so many places where you can get the data sets. Let's see what Apple has published as a data. Images. This data set contains synthetic captions, embeddings, and metadata for 12 million data set using pre-trained image set on a 12 million subset of data. Okay, this is all synthetic data generated by somebody. And so on and so forth. That's what you can do. Now, what happens when you use these pre-trained models, right? So you process your text. You process your text. The context there should be your reference text. You provide it to GPTs. So we use retrieval augment generation. So I will try to explain our pipeline at a very high level. Or why not I explain this? Azure OpenAI service is available in Azure platform. There will be some free credits also. Let's go through this from left to right. If you have 10 PDF documents, you can pass those 10 PDF documents to Azure storage. You push the documents, 10 documents about your college, or 10 documents about Bhagavad Gita, let's say, 10 different books about Bhagavad Gita. You store them in Azure. You have, and then there is a form recognizer that will review each page and say what it is. And what it does from all the 10 books, so the books written by different sages or the whoever today, pundits and so on, you pass it through form recognizer, which will extract different paragraphs, dialogues, and keep them as chunks of data, large chunks of data. Since a lot of it could be in Sanskrit or Telugu or Hindi or English, it will translate everything into an English by using an Azure translator. Then you pass it through the search layer. In the search layer, you convert all these. So now it is all chunks in English. The English chunks, when you pass them through the embeddings layer, where all the text will get converted into series of embeddings or series of vectors. These vectors are stored at some place, embedding of paragraphs using OpenAI. Let's say you have a vector database like Pinecone or Atlas of Mongo. You store the vectors over there. Now, here you look at user. User asked a query in Telugu. It translates into English. Or if the user asked in English, the question goes through OpenAI. OpenAI then converts the question into embeddings. These embeddings will go, or a vector will go here to the search, where there is a database of so many vectors already there. So it will look for nearest vector or nearest set of top 5 or top k vectors, top k paragraphs, and passes it to a question answering prompt, the prompt that we just created, right, as a context. This is where, wait. So here, the context here that we mentioned, or when we pass the context here, context is your top 5 paragraphs. That context goes, and your question is what the user asked here. So this essentially has both question coming from here and context coming from this paragraph. Now here simple question answering, right? Now you pass it and it is supposed to give an answer. That answer is shown to user. Now here you see what happened. In the whole process, the AI bit is working only at 3 places. AI bit is working only 3 places. Here, what we just saw in that example in our code, this one, 2 is embeddings here and embeddings here. So these are the only 3 places you notice the machine learning is working. Rest of the pipeline in this Q&A question answering model. So here you will have some sort of a chat interface. This could be a mobile app, this could be a web app, or whatever it is. Now that is built by some developer. Now the storage, you all know the storage, we can store things, and form recognizer, which is an extractor. You have an extractor. Then you have a translator where you have, and translated things are available as a data set. That data set is converted into vectors and you maintain the database. And only 3 aspects are used here for ML. Now, if you have to run that, how exactly in this case, these top 5 paragraphs are being used? This is called retrieval augment generation, RAG. So in fact, when I built a retrieval augment generation first time in March 2023, this was not even a concept. This was very, very rarely used concept. But then for our client, we had to build something like this. So when a user asks a question, you have your own database in the form of vectors all cleaned up. So that you will search for matching paragraphs over there, and you take relevant paragraphs from whatever is the size of Bhagavad Gita, and you give a prompt here, prompt injection. Say, what exactly do you do with this question and in the given context? You push these 3 things, prompt, question, and the context database, the relevant context, through a language model. Language model then gives an output. This is RAG. Now, finally, I want to show you one chatbot. I thought, yeah. Now, I spoke about this company where we implemented for 850 clients. Now, here, if you look at the pieces, here is the user on the left-hand side. User can have access chatbot through Microsoft Teams. We had a SDK with the Teams. Can access through Android and iOS, and can access through web browser. Okay. The user asks question, I pass it through my embeddings layer. Embedding then converts the text. We call it as an NLU, right? Converts it into a text. The text into a vector, and it does this. So whoever has asked this question, it gets the employee information from this query. So we are carrying the information. From the system, we get the role of the person. Now we convert the user query into some sort of an intent, a vector intent, and then we pass it through. We have 4 different models here. Like the way GPT has many models and horizontally multiple steps, we had a model of triggering event, individual information. But these 2 are simple APIs. We had some 130 API calls made to the overall HRMS application. Then we had a full-fledged language model under HR docs, what we just saw we just saw in the previous case, right? That was there for HR docs and for FAQs. So this intent is then checked with each of the 4 to see who has an answer with very high confidence level. So we carry, if there are 2 models that have very high confidence, we take both of them and we blend it. So now when we also use role, right? Role determines some of the HR docs, only relevant documents it will consider for the evaluation. And then we blend the response and give it back to the user. So it's very, very high level, but this is built. I'll give a pause to see What are your questions and your thoughts on this? Any questions, views? Okay. What what have you understood and what do you look to know more within the chatbots?
Hello, Molly sir.
Yes, I can hear. I can hear.
You can break, sir. Session is
No,
completed. Just I will.
asking if you have any question.
Participants, sir, do you have any questions to Molly sir? Sir, do you provide any resource material or any e-resources as we are in the teaching to learn this kind of subjects? Do you have any e-resources?
Yeah, so like I said, I wanted to show you Hugging Face for you to get data sets and most important to import libraries, pre-trained libraries. Now, Udemy is a platform where they sell courses for 400 rupees. And tomorrow, I also encourage all of you in your known subjects, you create a course. It is a very um, structured way of creating course. They ask for a subject, topic, video, or any video that you show, and text, and so on. So you also contribute to Udemy, and Udemy I suggest you consider for learning purposes. Okay. So any other view query that you have on the chatbots? All. So I wish you good luck. This is a short time, but I'm so happy to see the kind of course coverage that you went through and the kind of faculty that you have. Now it is like using computers. Chatbots is like using computers. If the way you could utilize is don't build a language model, instead just use a pre-trained model and do the pre-processing. I showed you retrieval augment generation (RAG). Do an RAG so that you will get very quickly a response from your split chunks. And the best wishes as you impart learning.
Thank you, sir. Thank you for giving the very good insights into the LLMs and the transformers and coders. We have given you a lot of discussion with the with the participants. Thank you, sir. Thank you very much.
Thank you. All right.
Nice
Yeah.
interaction.
Thanks.
Thanks to all the participants. Now we came to the end of the FDP. So I hope we conducted a very good FDP, which is explored your knowledge and which is very much useful to you. All the resources are resource persons are given very good insights and in depth of the subject of generative AI. I hope everybody has enjoyed and learned. You had some takeaways from this professional development program. Thank you all of you. In 1 or 2 days, we'll forward the certifications. We posted the Google form link in the WhatsApp group for the certification. By today, end of the day, please fill that form so that accordingly, on behalf of that name only, we'll forward to that respective mail ID, the certification. And second one is we are forward posting the 2 feedback links. One is related to the today's afternoon session, and one more is for overall FDP. Please fill both the feedback links. Thank you. Thank you, sir. Thank you very much. thanks to the black bucks who is associated with us in getting the resource persons. Thank you, Anuradha madam.
Thank you, Harshad.